Seen that movie? Okay. It's a great movie. It's a great movie. Yeah. Oh, thank you, thank you, thank you. Everybody get a piece of candy? Okay. All right. Well, don't forget, I just went ahead and sent out a reminder email, and I'll do the same for this evening as a text. Tomorrow morning is going to be the deadline for any outstanding. If you have an assignment or if you want to have a retake or anything of that nature, come on in 8:05 in the morning, because tomorrow we're going to try to get, again, as far as we can with the lesson, but we're going to go ahead and stop early to work on the district assessments, and then that's what we're going to go ahead and do on Friday. All right, and then Monday is a brand new 6 weeks. We're already 2/3 of the way through this semester. So before we know it, we're only a couple weeks out really from our Thanksgiving break. So it's going to be happening pretty quick. Okay, so what were we talking about yesterday? Well, we've been talking a lot about trigonometry and right triangles, so we're going to go ahead and kind of step away from that for just a little bit. We're going to start looking at oblique triangles. What does that mean? There you go. It's a triangle that does not have a 90-degree angle. And we talked about from geometry when you first saw this, the uppercase letters represent the angle measure, the lowercase are going to be the side lengths. And if you have what we call a pair, if you know an angle measure of a triangle and the side lengths directly across from it, well, you can use the law of cosines to help you find the missing parts of that triangle, whether it be an angle or a side. And the law of sines was just a proportion. The sine of angle A divided by side A equals the sine of angle B divided by side B equals the sine of angle C divided by side C. And then we went through several examples. I think we even got through the tree one, right? Okay. Well, we skipped this one for the time being just because of the diagram. So I went ahead and already had this created. So I want to kind of use this as our review today. Now, it says a person in a hot air balloon observes that the angle of depression to a building on the ground is 65.8. Now, on your paper, it says after descending, that just needs to be changed to ascending. So the balloon rose instead of going down. After ascending 500 feet, the person now observes that the angle of depression is 70.2 degrees. How far is the balloonist from the building? Okay, so if you're looking here, just a kind of scenario, when he first looks, you see this line in red, that's this guy looking at the building. And really, as long as you're looking at the same spot, it doesn't matter where on the building we go ahead and connect this to. I just did it to the corner here, the top one. So his angle of depression from his line of sight, if he's looking directly ahead out of the balloon basket, and that line of sight is parallel to the ground, from there, he's got to look down in order to see the building. So at first, he looked down 65.8 degrees, okay? Then the balloon rises 500 feet. Then he's much higher, so it makes sense he's got to look lower in order to see that same spot on the building. So the second time, he looks down 70.2 degrees. Well, the one thing about his line of sight and the fact that the balloon is going straight up, well, that's going to create right angles, okay? So when I take this triangle and I put it over to the side, I'm hoping that you can see where these values are coming from. Like, for example, this whole measure right here, we have the 65.8 plus the 90. That's where I got the 155.8. Okay. Now up here, again, because of the right angle, a portion of that is 70.2 degrees. Well, 90 minus 70.2 is what? It's 19.8, so that's where that value came from. Now, you'll notice over here in the one with the picture, the building, I don't have the 4.4, but what did I do to find him? If you've already got two angles of the triangle, yeah, there you go. We know all three angles always add up to 180, so I simply took 180 minus the 19.8 minus the 155.8, and that's where I got the 4.4. Okay, so after the balloon rose 500 feet, well, we're just looking for the distance that he is now from that building. Okay, so it'd be the side across from that obtuse angle. All right, so we have our diagram here. Now, remember, in order to use the law of sines, you need what's called a pair. Well, what pair do I have here? Yeah, we not only have 4.4, but we have the angle across from it. So I'm going to go ahead and say sine of 4.4 degrees over 500 equals. Now, if I want the one side that's labeled x, I have to use what angle measure? The 155, I've got to use that pair as well. So sine of 155.8 degrees, this is going to be over x. Okay, this is what we were talking about yesterday. How do I solve a proportion? Always cross multiply. There we go. So I'm going to multiply across, so this will give me x times the sine of 4.4 degrees equals, on the other side, 500 times the sine of 155.8. Ooh, just made it. And then how do I get x by itself? Divide. There we go. The opposite of multiplication. So I'm going to divide by 4.4 degrees. Sine 4.4 degrees. And just like you divide through by a coefficient, just a numerical value, you can do the same thing with a trig function. They're going to cancel out. So this right here, this expression should tell me how far away from the building the man is now. Okay, so let's see what that is. 500, come over here, let me get rid of this real fast. And I thought it would do that, so let's come back over here. Let's try that one more time. There we go. So control divide, we got 500. That's a 500, sorry. There we go. Times the sine of 155.8. And we were dividing that by, was it sine of 4.4? Okay. Sine 4.4. All right. So I'd say if we're going to round this to the nearest foot, he's about 2,672 feet away from the building. 2672. There we go. Questions? Yes, ma'am. Oh, how do we get that 155 again? Okay. What in the original picture helped me out here? Yeah, let me kind of zoom in real fast. Let me use another color here. So this portion right here, I'm going to zoom in on that. So we've got the 500 feet that the balloon went up. Okay, and we've got this. This is his original line of sight. Let's say he's looking at the building right here. Okay, and he's looking out across this way. Well, the angle of depression, it told me, was 65.8 degrees. 65.8 degrees. But his normal line of sight, if he's just looking out across the horizon with this vertical segment, well, that forms a what? That forms a right angle. Okay. So what I did was I just added this one plus the 90 in order to get that 155.8 degree angle that we have. Does that kind of help? Okay. And this is what we did yesterday. We were talking about the law of sines. Okay. Go to the calculator, yeah. Actually, not right now because we're on the... Yeah. Sure. Now, I'll have to do it. I can't let you do it. Okay. All right. So let's see here. I think, didn't we already... We began talking about law of cosines, right? I don't think we did any problems yet. But let's see what we got here. Now, let's say that you come across a triangle, which is very likely, where you don't have a pair. What does that mean? I keep forgetting things. Yeah, remember, a pair means an angle of the triangle and a side directly across from it. You need that in order to use the law of sines. But what if you come across, say, a triangle like this that only has the three sides and none of the angles? Okay, well, that's where the law of cosines comes in. It still allows us to find everything about that triangle that we want. So we were talking yesterday, whatever side length you start with, you end with the cosine of that angle. So see, I started with side A. We end with the cosine of angle A. If I start with side B, I'm going to end with the cosine of angle B. Now, also, whatever side you start with, it's the other two sides that you have to manipulate. First, we want to square them and then take their sum. So like b squared plus c squared, and then we subtract 2 times their product times that cosine of A. And if you look at all three of those, it's the same thing over and over again. You're just using the different side lengths. Now, we're not going to be lucky enough, unfortunately, to have all of our triangles labeled as ABC, so the formula might change from time to time. Let's say the triangle was named XYZ. So this would be little x, little y, little z. Okay. Now, let's say I wanted to go ahead and start by finding angle Z. Okay. Well, what side would I start with if I want to find angle Z? Yeah, I'd start with side Z, right? So I just follow this pattern here. I'd say Z squared equals, well, the other two sides are X and Y. What would I want to do with them? Okay, so I'm going to square them both. So X squared, Y squared. I'm going to add them up. Then what? Minus 2 times X times Y times the cosine of what? Angle Z. Okay. So it doesn't matter what you name the vertices, the pattern is always going to remain the same. Okay, is everybody okay with that? Okay, I can go ahead and do another one. Let's say that the name of this triangle is KMN. Okay, so this would be little k. This is little m. That's little n. All right. And let's say I wanted to go ahead and solve for angle K. Okay, or even side K for that matter. All right. So because I'm looking for that, I'm going to start K squared equals. Well, what would I do to the other two sides? Okay, so that would be m squared plus n squared. Okay, minus 2 times m times n times the cosine of what? Angle K. Okay. That's the law of cosines. Okay. Now, here's what's really nice about this. All we're going to have to do is plug it into the calculator. We're going to let the calculator take care of that heavy lifting for us. Now, in order to get it in the calculator, we're going to have to do a little bit of manipulation, but it's nothing horrible. Let's get to an example, and I'll show you what I mean. It says a triangular area of lawn has a sprinkler located at each vertex. If the sides of the lawn are 19, 24.3, and 21.8 feet respectively, what angle of sweep should each sprinkler be set to cover? So basically, what are the three angle measures of all your triangle? Okay. So I always encourage you, if there's not a picture, go ahead and just draw one. It just says a triangular area, so we just need a triangle. And I'm just going to go ahead, since they have A, B, C here, we're going to be using A, B, and C. Okay. So across from angle A should be 19 feet. Across from angle B should be 24.3 feet. And C should be 21.8 feet. So I'll say 21.8 feet right here. Okay. Now there's only one bit of advice I can give you about the law of cosines. Now, without going into the reasoning why, if you want me to, I can absolutely do that. But I would always encourage you, start with the largest angle. Always, always start with the largest angle, and you should be perfectly fine. Now, we don't know any of the angles, so how do I know which one would be the largest? There you go. We remember from geometry, the largest angle is going to be opposite the largest side. So I'd want to start by finding B. Okay. The reason is, well, in fact, I'll go ahead and wait until we get this first part done, and then I'll go ahead and kind of go into the reasoning why. But if you have to use the law of cosines, my number one rule, I would really encourage you, start with the largest angle. Okay. So let's say I want to set up an equation based off what I have here. Well, since I'm trying to find angle B, well, what side am I going to start with? Okay. Let's start with B, right? Okay. So I'm going to go ahead and copy this formula down here. B squared equals A squared plus C squared minus 2AC times the cosine of B. All right. Well, we know that side B is 24.3 squared. So I'm just going to plug in the values that I have. So now A is 19, so 19 squared, plus 21.8 squared, minus 2 times A, again, is 19. C is 21.8, And now we have cosine of B. Is everyone okay with what I did? Okay, who said no? Okay, Lilybell? All right. So are you okay with the fact that side A is 19? Because the side is always going to be across its respective angle. So if I have angle A here, then side A has to be across from it. Same thing for B and the same thing for C. So all I did was take my formula, C in place of B, I put the side length directly across from it, 24.3. A, I substituted in 19. C, I plugged in 21.8. The formula is given to us. That's something we don't have to derive. The formula is just provided for us. Okay. Now, you remember what I said? We're going to have to do a little bit of manipulation in order to put this in the calculator. Okay. We need to solve this for the cosine of B. So I'm going to kind of walk you through these steps here. Any terms that are individual, these guys by themselves, we're going to go ahead and subtract them over first. Okay. No, we're actually not going to square them. We're going to let the calculator take care of all of that. So the only thing I'm going to do is take these two squared values. I'm just going to subtract them over. So I have 24.3 squared minus 19 squared minus 21.8 squared equals negative 2 times 19 times 21.8 times the cosine of B. So really 2 steps, we can put it in the calculator. Okay. See, now, if I want to get cosine of B by himself, I've got to divide by this product I've got in front. And remember, we're dividing because what's the opposite of multiplication? Yeah, we're going to divide. Okay. So I'm going to divide this side by negative 2 times 19 times 21.8. I'm going to do the same thing over here. Negative 2 times 19 times 21.8. So all of those guys are going to cancel. See, now I've got cosine of B is equal to this expression. Is everybody okay with what I did? Subtract the 2 first terms over, then divide by that product. Okay. Well, now, let's go ahead and figure out what that is. Let's put it in the calculator. Okay. And see, we're not even going to know what these individual squares are, and we don't have to. It doesn't make a difference. I'm going to come on over here. Let's see. I'm sorry? Oh, yeah. If your calculator is in this, if your calculator is in radians, if you go back to your home screen, go to settings, then you're going to want document settings. And right here at the very top, the second tab, it'll say angle. So once you now, and this is very important, once you choose degree, down here, don't click OK, click make default. And then, are you sure you want that? Yes. Okay. So let me get back over here to my calculate screen. So control divide. Let's type in what we had. 24.3 squared minus the 19 squared minus the 21.8 squared over negative 2 times 19 times the 21.8. Would everybody agree? So this is the decimal that I'm going to get, right? But that's not the measure of angle B. Okay, this is what cosine of B equals. So I'm going to round it to 4 decimal places. Let's say 0.2967. Okay, so 0.2967 is equal to the cosine of B. Now, you remember, it's been quite a while, but Miss Stern covered this information with you. If I'm trying to find the measure of an angle, what am I going to have to do to this? I've got to take the inverse. Angel's absolutely right. Because remember, when you plug an angle into a trig function, it gives you the ratio of the sides of the triangle. Well, that's what the point 2967 is. We have 2 sides of the triangle in a fraction, but we want to know the angle. So I'm just going to take cosine inverse of that value, and that's going to give me the measure of B. Okay. Now, you'll notice I went ahead and rounded it so I could write that number on my paper, but when I go back over here to the calculator, if you hit your trig button, the second row, all of those are your inverses. So I'm going to hit cosine inverse and use the exact value. Okay. And now I'm going to go ahead and push enter. So let's say it's about 72.7 degrees. Okay. About 72.7. All right. Good, 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 good. So this guy right here, 72.7 degrees. And there we go. Okay. Now, here's what's really nice about this. Okay. If you want to, you can continue using the law of cosines, but I don't have to. What did I just give myself by finding that angle? Yeah, didn't I give myself a pair? So now I have an angle and the side across from it. Okay. Now, it doesn't matter. If you go ahead and stick with the law of cosines, it'll give you what you're looking for. Or you can go to the law of sines. What would you guys prefer? So you want to go with law of sines? Yes. Okay, so you want to go to law of sines. And that is why I went ahead and encouraged you to always look for the largest angle. Don't worry about the reason right now, but a lot of people, if they have to use the law of cosines, as soon as they can, they like to go back to the law of sines. Okay, well, you're not going to run into any problems if you always start with the largest angle. Okay, so somebody help me out. I need a proportion that's going to help me solve for one of those angles. I know that we have to start with sine of 72.7 degrees over 24.3. So it just depends on if you want to find A or C. A. Okay, so what would that be? Sine of A over 19. Because remember, we don't know what angle A is. Okay, and here's one big distinction. You only have to take the inverse if you're looking for an angle measure. If you're not looking for an angle measure, you just solve the problem as normal. See, here we needed angle B, so I took the inverse. Here I'm needing angle A, so what am I going to have to do? I'm going to have to take the sine inverse. Okay. All right. Now, I know that's a lot for just the one problem. Okay, but let's go ahead and stop there. Tomorrow we'll pick up on this again because I do want to show you something before you take off.
Can't you just multiply by 19?
Can't you just multiply by 19?
On both sides to cancel that.
Oh, yeah. In fact, you could go ahead and do that. Yeah. Instead of cross multiplying? Absolutely, yes. That will work. Okay. So I'm going to leave that there so we can go ahead and come on.